right? So that you can go through these things again if you need see it, right? So the idea. Let me just to take the first thing to 127. Okay. I'm going to divide this by 2. Right, so 127 will write as 12, we have 6 and 2, 3. All right, so I was saying about this part, right? You can try with me. So for this is 6, and for 7, again 6, and no, like I hope you are able to do try to if it's hard to do this one, if you are more comfortable with the long division, that's also fine, right? You can just do it this way and find the answer like this. Okay? And for 7, it is 3 and 1 is remaining. What is important is we need to get the remainder here. Right? So the remainder is 63. We have 1 remainder. So to get the binary, we need the remainders, all the remainders, right? So that's why we need it. If you have any questions, let me know, right? Okay, so like that, just go with the flow and try to get the say yeah, this is 1, okay, and 1 is remain. So here again 1. So
Teacher had to divide only from 2, right, teacher?
Yes, because if the binary we are going to convert, we are dividing it by 2, right? So if you are going to get these values into octal, right, you have to divide it by 8, right? So always when you want to convert into that particular form, you have to divide it, if it's octal, divide by 8, right? If it's hexadecimal, you will be dividing that value by 16, right? So that's the format that we need to know, that whenever we are going to get any value to these conversions, you have to remember for binary, 2 is the one, for octal 8, and for hexadecimal, 16 is the answer. Okay? So you'll be getting questions to convert like this. So just to remember this, I'm writing it. So to convert any decimal, you need this, right? So to decimal, any decimal, if you need to convert, this is the form that you have to understand. Because to be some easy way, right? So the easiest way is this. So any value like from binary decimal to binary or binary to decimal to octal, decimal to hexadecimal. Because this is base 10 for decimal, this is how you get it. Okay? So for 7, we have 14 and 1 is remaining. And this is 3. Yeah, right? And 1 is remaining. And I just gave this 1 to 7 so that you can see the answer is all ones. Right? So whenever we convert 1 to 7 to binary, this is the answer. There are 1, 2, 3, 4, 5, 6, 7. 7 bananas. 7 binaries. Right? So like right? So this is in binary form. So what did we do? We convert 127 decimal value to be continued. To convert it to this form. Okay? So you can always
Teacher, they
yeah.
have six ones, so teacher? Six ones for the answer?
Yeah, there are 6, 7. You have to go from the beginning, from this side. 1, 2, 3, like that. There are 4, 5.
Teacher, are we counting that one teacher under 3?
Yes, this one also we have to count because this is also a remainder out of this value. We are not going forward and get the minus or like dividing, say, decimal values. We are not going to do that. So this is also a remainder, right? So because of that, we are taking that as well. A good question. So if you convert, we can just check if we are getting the correct answer. So it is all 7.
Teacher, that is 0. 0, 1, 1.
Yeah, because we are getting it in 8 digits, right? It comes to binary, we get it as 8 digits. That's fine. We don't need to add the 0 in the beginning. It's how calculated it is. So if you are going to do something in show that good let me again here. So say I'm going to do 10 and you need to check what's the binary. So it's saying as 1010. Okay? But when it goes to right, so like that, say I'm going to do 100. You can see the answer is this one 01100. But because we are going for the next set of 4s, right? So when it comes to binary, we are taking 4 by 4 digits, right? So that's why whenever we are going above, 4 digits, it is taking whatever the first digits as 0, right? So say not this much of a value. Let me do 45. Okay, so you can see these binaries 101101, right? Because it is going for 8 digits, they're adding 2 zeros in the beginning, right? So whenever it is going beyond 4 digits, this is showing as 2 digits as zeros and getting a 8-digit value, right? That's how programmer calculator is programmed, right? To give a value in 8 digits. If you are going for a middle, this kind of a 7-digit value, you will add a 0 in the beginning. But when we are writing it, we should not do that thing because we are not getting a 0 here. We only go up to 1 and stop it. Right? So this is the correct answer that we can easily get. Okay? So we can try. I give another number so that you can try. Right? This way, same way. I'll give around say 255. Okay? So if you could get the binary out of this number, we can see if you can understand what we did. Okay? So that's the main point of doing this. 255 decimal to be converted to binary. Slowly do it the same way like this division. Do it by multiply, sorry, divide it by 2 and we can find. So I got to do a 3-digit number before going for 4 digits here. That's why I thought to check with that first. And if this is okay, we can easily do this kind of a question like this bit. Fine. If you can just give the answer and let me know and make sure to not to use the calculator here because it is only for validation. Right? But in exams, you will not get a calculator to do these simple kind of you know calculations. Right? So always you have to go with the this thing. It's a normal calculator. Like that. So you can easily, I think, try to do this one and let me know the answer. You can edit it into that, how you got it. Anything is fine.
Teacher, do I need to do all the questions, teacher?
Sorry.
Do I need to do all the questions, teacher?
Yeah, going for this one. This one, then we'll do this. And then we can go for workbook questions as well. So if you get the workbook, there will be another set of questions as well that you could answer. it's hard, we'll do it together. It's not that much hard. Let's start with my one. You can also.
Teacher,
Yeah.
answer is 1, 1, 1, 1, 1, 1. They have eight ones, teacher.
Okay, 8 ones and 1, 1, 1. What's the other one? Is it? I think here. Last. Can you please tell me again so that we can check if your answer is correct? Let me do it from the beginning side. So for 1, for 2, 1, and there's no remaining. For 5, we are taking 4, that is um, so we are taking 1. Then for 5, we have to take 4, which is um, 4. This is 2, and 1 is remaining. So then for 15, we have to take, right? So when we are dividing 2 by 2, 1 is remaining. Right? Then we have the 5. So 5 divided by 2. 2 is the answer and 1 is remaining. So we take that to next one. And for 15, we are taking now. And 15, 7. And we have 1 remaining. So six. Okay. So what I did, I just got the total thing out of right. So 63, 60 and 1. The same way, right? I just added another one top of it. And yeah, this is the same answer we take. Just one more, 1 is added because you need to add 8 digits, right? So this is how we add it. Uh, 16. It's a 16 like that. So the answer is taken in this order. Yeah. So you understood, like we are just adding the thing that is on top in dark, and that's what we are doing. So for 15 is 7, 1 is remaining. Mm, So we have to take from this to this. So the yeah, 2, 3, 4, 5. Uh, 5 ones are there. Uh, so I will add 8 ones. Hmm, excellent. We have the answer under 3, 4, 6. So this is into base 2 because it's the binary number. Right? We can check as in the calculator, same thing. Uh, Convert to any form and see if we got the same answer as here. So I'm just going to say to yes, mm, X, so we can sorry, we put this sorry, we can get all 8 numbers together. So there are same way all ones like this. Okay. So we can do the same way for this number. Right? So if you can try to get this big number, right? You have to do from the beginning one by one to get the correct direct decimal to binary form of this one. You won't get any values more than 4 actually, right? Only 4-digit values can be given for grade 8 for conversion, right? There will be one question based on this in your part 2 questions. Definitely one or two questions in your first paper in master MCQ, right? So those are the ways.
already.
Answer.
That's the second question, teacher.
Yeah.
Decimal to uh, yes, 1 0 1 1 0. Can I send it, teacher, to the Zoom
Yeah,
chat?
yeah. But I just want to check if you're able to understand how to do it without me, so that easy. Okay. It's the binary format of 1005 406. Let's see, 6 months. Uh, we check the answers. Correct. Um, Time. And try to do it quickly. Uh, okay. Um, so it's one. Nothing is remaining. Quickly do this answer. It's remaining, but can is 5. Okay, so okay. So I just got this value 351. Then um, showing these um, 5. Right? Mm, 20. This two. It's one remaining. What's this? So yeah, answer I think we'll see. Sorry, but I think check if your answer is this one. It's so I will write like this one. Uh, Yes, for the answer, I think I'll check it from here if I have got the answer already. Um, um, check for um, the huge value. One, yeah, so I got like 110. I think it's wrong. Others, let me help. Uh, I have to check again from the beginning, but still, this is to here they will not get a value. I just added it so to I can show that there can be values more higher than this as well. So this one you have to convert to decimal. Right? So I'll do one. You can just check on that. Okay? So uh, Okay. So I'm going to get this 1, 1, 1. Okay, so there are 7 ones. I'm going to convert it using 1. 1, 1, 0. Mm, four. And 2 is the base, right? I think small mistake this side. Can add the base values like this. Mhm. So when you are asked to do this, you have to get all the things multiplied by 2. Okay? Whenever you are going to get something from decimal to binary or decimal to octary, you just divide it by the value. So here, yeah, getting the amount and we try to compare it. Think so. Like this, we can. I hope you remember this table, right? Whenever we do this kind of ones, this table is a must, right? So you can see I have done another one here. We are doing it with this table. It's easy to carry the work. So remember this table in order to work. Hmm. Starting from the left, rightmost one, you have to say 1 into so here I'm just trying to get the values, right? So 1 into what's the 2 to the power 0 value? It is 1. So we are getting 1 into 1. So left, so rightmost one we are taking. Next we are getting 2 to the power 1, which is 2. So it will be 1 into 2. So like this, the whole value has to be translated. Hmm. Next, 2 to the power 2 is 4. So we are going to get that. Next, we took to the power 1, 2 is to be taken 1 into to the power 3. Yes. Mm, Let me get it right. So we are just adding the values now to a certain thing. We add the 4. So mm, like this, just add all the values. We just substitute it. Okay. 1 to 4, then 8. Did you get it? Rehan? Any questions? Or thank you.
Yes, teacher, I got it.
Got it right. Then we are adding it. Okay, so up to 1, 2, 3, 4, 5, 6, 7. So there are 7 ones. That means we are going up to the power 8. Sorry, 7. So the answer is for this 1, 2, 7. That means the total of all these values, right? 1, 2, 8, 2. Okay. So if you just get that way, that is easy. When you are more used to it, don't need to go one by one and do it, right? You can just go to this binary and give the value as all ones, like yes. So all ones. Yeah, this is 8 ones. So 1, 2, 7. So let's so this is 255. Okay. So because it's going up to this much, we are going for 255. So total is 2. It's all of them is to be added in order to get it. Um, so always when you're asked to write the answers, please make sure to write it all the things that you did. for that question. Mm, So, so like this, we can just get all the values and set we can do. So, what we are going to do is we will go into this line, question, and if you can tell me the version, sorry, the decimal of this value, we can be more sure about. So, the value 101010. Okay? So we are going to get that value. Like you said, digital video sounds. Mm, like a temporary occasion when it comes to memory resistance, right? So when it's in diagrams, you will see something like this. Mm, so this was some arranges for you to check on that. So you can get the values like that. Mm, so this is this one. Yeah. So we think we are with done. Uh, like this, we can try to do the assignment that I have given. It's more into writing stuff. So if you can write it, that would be great. Yeah.
Okay, teacher.
All right. So the answer from this one, got?
For the first one, teacher.
Yeah. I think the first one.
Teacher,
Yeah.
that is a binary number, no teacher.
Sorry.
That did you have given, teacher?
Yeah, this is binary. You have to convert it.
So teacher, they should only have 1 and 0, teacher.
Yeah. So we have to get it in this form, right? Like this way. Like in here, you have to get this one separated. This one like this. All of them just separate it. Then you have to write just like here. We wrote these ones. What we are doing, we have to match it with the zeros here. And so this is 0. You have to update it as 0. This one, so you can keep this one. This is again 0. Remove it. Right, so I'm referring to this. This one. One. Right. So this one and so always you have to get the values like this. So we are actually not using these now, right? We are using only actually this one. We are using only hexadecimal now to convert things, right? We can't go other than that. Right? So here we took this 0 and this this one here. And so 1 0 1 0 this 2 we can take and this one we should not take this because this is 0. And so like that we can update the values. And so this is 0 and this side is 1. So 2 into
Teacher,
yeah.
I can't see that, no teacher.
Oh, 1 minute. That means okay. I think I'm doing it here, right? Sorry, I think I haven't given you this. And so I was doing it here, right? So, sorry. I think some this thing sometimes get lost in the between when we are sharing our screen. So, mistakenly, I have clicked on pause share. So that thing happened. Okay, like this. What I was referring to is this 0. Because of that, I just change it to this 0. Because it's 1. This is 1. Because this is 0. we have to get here this one, this has to be 1, this side 4, but because it is not available 0, we have to say 0 into 4, like that. This is with this one is this one, like this we took, and this one you can't take because this is 0, right? So we are just applying the numbers like this, and no need of this, and get it in this way. Like this. So now we have to only get the values with only that 1 is going to get multiplied. Okay, so we are getting 32. We are removing 16 because it is 0 into 16. This is 1 into 8. So we are taking 8. This is 0 into 4. We hand to it is 0 again. So we are not adding it. So even you can say like this way. Whatever the things that you come from the top bar, we have to get, okay? Like this way. This is 0 into 4, because of that is 0. 1 into 2 is again 2, and last one is 0 because 0 into 1 is 0. Okay? So this is 32 plus 8 is 40. 40 plus 2 is 42. Okay? So you can check always, as I said, in calculator. If you get easiest is 42, and see what is the binary of that. So it is 101010, right? So answer is correct. So this is how you take it, right? You're just adding so 32 according to this table we do it, right? So this is related to these ones as in here. So 255 thing, I think at that time also seen and paused, right? So now only now saw it. So this one we are taking as this way. Okay, so the other. So here, how did we get this 255? We are just adding these values, which are getting 64 plus 32 from here. From here is 16, 8, 4, 2, here, we're taking, okay, and 1 from 1 into 1. So altogether it is equals to 255. That is the value for this. Okay. So like that we can do any number can be taken and converted to binary, and binary can be converted back to this format. Okay? So what we are going to do is because we are in the end of the chapter, right, we will try to answer these questions here. Right? So in here, as I have mentioned, these are the 4 types of number systems, right? We have decimal, binary, octal, and hexadecimal. Right? Now, because it's a lot of things are getting converted, we are in hexadecimal. format whenever we are adding any color or anything. But earlier it was octal, binary, and decimal. Okay? So in number systems, you can feed images, videos, right? So anything. So here, type of data that can be fed by humans, you can write them, right? In the activity note that I prepare. Okay? So always write it like this. Videos. Um, okay, images, videos, like that. Text, anything in these forms can be converted to numbers, right? So, images, videos, text, any file format, actually. So, what else? We can even get books to be converted in to human as humans. We use all of them. Other than that, we can use the executable files, right? So like softwares, if you're going to install, you will be getting .exe files. So executable files um, that we all install when you are putting a new computer. .exe can make it. So this is another type of thing that we should know. Okay? So how can you write about this part? What is the meaning of number system? Right? So why do we have a thing called number system? Okay, that's the important part. For this one, we have to write uh, what can we do with the number system, right? So for an example, we can easily convert anything, right? Any type of a file like this. Um, we can convert images, videos, text, any of these files into computer understandable language, right? So the meaning of number system is that, right? We so we can say able to convert um, to computer understandable language. Right? So this is the way that we use it. Other than that, you can see like why what do we use? We are using ones and zeros as in binary format to I get an idea how computers understand things. Can write it. Uh, able to convert um, English language code to any language. We can then edit it not only in this thing, right? So I will see. Let's see. We have to say binary, any form we are able to convert. So, binary, hexadecimal, and octal. This we can write about a lot of things. Did you get this paper activity, this assignment printed? Do you have any? You couldn't get it.
Is in your Google Drive, teacher? No, in the Google Classroom, teacher.
Yeah, it is in the Google Classroom. You can take it as well. So here, this is the base. I think first recording, first class recording as well, I have added it. So you can see. So I have, I think, update it for you as well. So you can get it with the activity. So this way you can take this activity. Let me just check if I have added your name to this. Yeah, your name is here. So please take all the notes that I have added. One is this activity, other one is note. And if you need the task recording of the first lesson, you can take it as well from here. So next, this is about last year's things, because just now we started the new intake. So this is from last year, configuring formatting. So it's the kind of the thing to do pretty much. Yes. Uh, so we were here. I think once. So we are able to convert any thing into here, this language. What else can you see? You can see images, videos, anything can be converted. Right? So what else is um, So, like I said, these are the things that you have to write that using number systems, humans can use computers for easily, right? So, say you want to add something as in a robot, right? So, you can easily introduce new things if you know the language of the number systems, right? So, able to introduce new uh, features or new functions, you can say. Can write it. So types of number systems. There are four types: binary, octal, decimal, and hexadecimal. Right? So I'm just writing it down. You can take if you want to write it, you can write slowly in your notebook if you have one, or else you can take the note from the classroom, and just like how I do in Microsoft Edge, I can type the answers. You can do the same, and it will be saved for your life, right? So you can even use it when you are not there. So, like I said, it's important. So, can you tell me the next one? What are the numbers of these particular number systems we have added? And what is the uh, yeah? So let's take some. You can write it out as well, so that you need to go again to the next. So according to the number systems that we added, we have to add the numbers of each system, right? So for an example, if you take the number system, binary number system, we have how many digits? We have only 2 digits, and the base value is again 2. And then we have to consider our decimal. So decimal numbers starting from 0 and 1. Ekathatri. Then uh, this is actually number system, one column. Right? So decimal, we have 10 digits, and you have to mention all of them, like 0 to 9 is the answer. Right? So I think I ended it properly. 9, 9, yeah, 9, 9. So then characters, we can get any design from 0 to 7. There are 8 characters. Because we are starting with the 0, we have next is base value is 8. Base value is 2. Last is hexadecimal. This what do you call table is important. So it's better to write it down. It will be easy for you to remember the things which are very important. So you write these 3 things in your book or in your notepad, anything, because there can be questions like this in your papers, right? Because unit 1, you can have it in first term, second term, and third term as well. Right? So when you're going to O levels, even you have the number systems. So all of these number systems, you have to convert the normal numbers to every single number system. Right? That's how we do it here. Okay? So I have zoomed in and I have taken to the uh, place that you can get the right. Slowly write it down so that we can go.
Okay. Teacher, I'm finished.
So next is about the noun verb conjugation type. So, I only call this noun is also okay. So here these is about the number system digits, right? So in here you have to mention like 0 and 1 are the number system for the binary and other groups. Right? So full form you have to mention all of them, right? So I'm saying like that way. 0 is 1, 1 like that. We can mention all the numbers so you will not forget what are the correct numbers for each ones, right? So like this, if you have 0 to 6 and 7, it is octal, right? There are octal means 8. So like this, we can get the number system values, right? So if you have seen like robotics and all, we use these number formats to introduce new things to the computers, right? So in our Python is a another type of programming language which gets new things. We can write it in English and convert easily to number system format, right? So like I said, it's the way that a computer understands, right? Yeah. This is important to convert things to hexadecimal right now, but by the time from next, you know, you never know, hexadecimal might not be enough. Then it will introduce another number system to follow and give more commands to the computer. right? So like that is as of now. Right? So I'm just adding the rest of the values. As in here, we have 0 to how much? We have 0 to 9, that is decimal. Right? Like this. And last, we are adding the octal, which is 0 to 9 and A to F. Okay? So these are some activities given by the syllabus to do, and so that's why I have added it. And we will not remember, forget all the values when you by uh, doing this. You can remember it easily. Okay? 5, 6, 8. So A, B, C, D, E, F means we are adding A is considered as 10, B is considered as 11, C is considered as 12, D, we are adding D as 12, right? So 1, 10, 11, 12, 13. So there also we are getting up to 16 in A, B, C, D, E, F format, right? So that we can easily use these forms, right? So not only for the sake of giving something new to read, to give some shadings in colors, we use it, right? I hope you remember, right, in Paint, uh, how we use the hexadecimal to show the colors, right? So easily you can just use these color coordinations and all, and get the hexadecimal value together. Right? So together these three values, you get the hexadecimal value. Right? Something like that. Red, green, blue, CMYK, like that. So it is related to colors. It is related to coding. How we enter new things to the codes. So yeah, this is about it. Okay. So please write it, and you can easily do it in Microsoft Edge, right? So once you do it, you can take a printout of your activity book from the beginning onwards. Whatever you typed, you can take a printout easily. That's the way. Okay. So slowly write it out, and so humans are familiar with but decimal number format. Okay? So we are using the normal ones as decimal. This is the okay? So base value of that is 10, and it has 10 digits as it. Okay? So these are the important points of each number system that I have added. 3 sentences here to show that, right? So these are the important 3 points of number system of decimal. Right? Same way, if you see next one, I have added for binary. What are the 3 main things that are important? Same way, it's all of them. And there are some more things for you to understand about this. Right? So I think it's a good place to then write these things down, and we can go for the next part. And hope I just added the answers, right, without asking you, because this is an easy one, right? I'm going to ask in the next question, what is the answer from your side, right? Because these are easy stuff. Decimal is the one that we use, right? Yeah, that's right.
Okay, teacher.
All right, kid. So this is also same, just to uh, make it more easy for you to remember the digits. This is an activity. So you can just fill it out, the values that we can refer. Yeah, five, mm, so like this. This is about the counting frame thing. So you can just count how many numbers, like in our as children, we used to do this, right? So there are 1, 2, 3, 4, 5, 8, 9. There are 9 hundreds, right? Then this is in decimal form. So this is how we work with this. Next, it is going to be 3 tens. So that means 30s are there. And 1, 2, 3, 4, 5,
Teacher,
yes.
now teacher, these days teacher, what are they using teacher? They are not using binary or decimal or teacher.
Actually, they are not using it. For an example, say, right, so there are some values. Say, you want to get Nihan printed in your any of your code, right? So to do that, there's a specific code, right? For n, there's one code. Say 01 is for n. So you will repeat it because you have another n in your name, right? So if it's NA, so there are two NAs, so we are getting that way. So then say E is 0, 0, right? So there's no another E required. Like this, we are getting this in binary form, like this way. So it is this way, and we'll get um 01 as we can say it is like this, right? So to do a particular task, this is the code in binary, right? So like that, in decimal, like when we are having something back to ourselves, right? Good question, actually, Nehan. So when we
So
want to
teacher,
get
they don't use the hexadecimal that they don't use those teacher instead of binary.
no, we use it, right? To give something to the computer, something new, we have to use the hexadecimal format so that computer will say, oh, this is a new thing. It will understand this, right? So decimal, we are using it to get it back to English, right? So we are giving something in English and it will be converted to binary, and if you want to get it back to uh, English format, you have to get it into decimal format. That means to get it
Yes.
in English.
Uh,
Yeah.
teacher. So
Yeah.
teacher, how are programming languages coded, teacher?
Yes, so coded in the sense, if you see Java, um, yes, is it Python, right? So Python code, you can always search, right? So, so there is a specific way to store things, right? So if you go here and it's it will show you. Yeah, what should I call? So, like I said, always whatever in English will be converted to this language because computer does not understand it. You can see source code, byte code, then binary code, right? So we have to get this into byte, then it will be going into binary section, right? So then only computer will understand. Right? So we don't know, but inside the computer, this uh, conversion is happening, right? So this is only one example of it is in Python. Same way for each language, we have compilers, right? Because good question actually you asked. So Java, it has a separate compiler called Java C, right? So it is getting converted to this language. Then say we are using Windows, you can get it into Windows and run. If you are going to use it in Linux operating system, you can use it this way.
Teacher,
Yeah.
how are those decimal numbers are created, teacher?
So decimal thing is like when we want to get it back to us, right? So say Java first compiles and uh, actually we have to get it back to decimal form. Which one? Um, so we get that back to English, right? So I think to take this thing. Um, in Java, we are using bytecode, like I said. So to get it back to English, there has to be a mechanism, right? So whenever we say something to be ran, so this is a application that is running in English, right? So to get something from French to English translated is an app developed by Java, right? So to get these things back to English, as in the interface, right, there has to be a mechanism. So we are using it to get it back to English. There has to be some middle path, right, middleware, where, so that is called the decimal number system, right? So we can't easily convert whatever in hexadecimal to the binary code, right? So as in normal way, for your question, this is the answer. Let me just show it to you, right? So just draw it and yes, please. That way. So say I'm adding some code which is in source code. So I'm writing it like this, and we are converting it to bytecode. Right? So I'm getting from the beginning so that you can understand it better. Right? Then this is like something in between. It is getting happening. Then this bytecode will be translated to binary. Right? Next is translated. Then, oh, now computer understands this is binary, right? So to do that, we need binary. Right? Next, your question is about how we get it from binary to English, right? To do that, now the computer will, the computer and computer will, execute the code in our system, right? So that is how it happens. So I'm writing this like this way, right? So next, you can't immediately convert it back to, hexadecimal, right? So you have to have a middleware where we can get it into decimal, because that's the easiest way to get it into English, right? Because we can convert things easily to decimal format, right? So say this, whatever you need to get it back to English, first you have to get it to decimal, then only you will go into the next level, right? Actually, before this, it will be converted to uh, hexadecimal first, then decimal, right? So, because computer will give the answer in this format. So, it is back to whatever the language, not only English, right? It can be Japanese, it can be any language that computer needs to be executed. So next, you will convert it to decimal, and then you will see the things in English afterwards, right? So this is the way that a user will see the user interface with English. So UI. The user interface has to be in English form. So to do that, this is like the bridge, right? So easily you can convert from hexadecimal to decimal, then to this, right? So again, if you are going to convert, you have to convert it back to bytecode and do it, right? So again, it will be converted. So to get it back to this order, you need to get it in decimal. So that is kind of the bridge where we can get the things in between we need, right? So that's just to get the idea, like Why we use it? Because easily we can convert things from decimal to English rather than going from binary to find each code for each letter. It is easy to convert from decimal to English. Right? So this is the order that any code that you will run, it will work this way. Right? Not only code actually. Say you are entering some input, right? Computer will not understand English, right? So whatever you insert from your name, say that will be in English. From this side, you will enter it. So that will be again sent into the computer is as in bytecode. Again, binary will be converted. Then only computer will execute that your name is inserted into the system. Right? So like that, this code thing goes as kind of a life cycle. So to make it easy for to do this life cycle smoothly, right? To do it smoothly, you need decimal in between. So that's the way that I can say. Any question on this part?
Not teacher.
Okay. So yeah. So, like I said, nowadays we are not using more into this binary thing, right? Because byte code is something like objects. So, say if you are going to enter some values, it will be taken Nehan as an object, right? Your grade as an object, right? So, byte code is something like that, which will be taken as objects each of the things that we enter, right? So easily you can get a binary code attached to it and execute, right? So this is how compiling happens, right? So to be honest, there's no place that I have my this. Mm, okay. Mm, let's see what. So I think between um, as I was going through, hope there aren't any images or something like that to give you an idea. That's why I thought to show it from here. Okay? So any language can be converted. Right? So we will see the next couple of things on next day because binary I think these things you can answer, right? What I want you to do is try to do the workbook activities if you can and come on next day because I think if you can try to do these conversions as well because as much as you
Teacher, I
do
had to do those activities on this in this
yeah
PDF, teacher.
yeah there are
Okay, teacher.
activities here, right? So easily you can do those activities. And there are some questions here. This is a term test question, first term test question that I have added about this on, off, and all of them. So we'll actually discuss these things together. I think you might need me for this one, or else if you can definitely do. So if you are comfortable, try to do as much as you can. We'll meet on next day because I have a office meeting to attend at 6:30. So that's why I will wrap up here. Otherwise, I will complete this part up to binary here. Right? So yeah.
Okay.
See you then on
Bye, teacher.
next Sunday. Okay, see you. Bye. Have a good day.